So, welcome back. So, we have explored the model, our AI exporter, and also the dataset, which is the study material. We discuss about the utilities as a helpful toolbox and configuration as a rule book. Next, we talk about the predictor, which is the engine for applying the model, and finally, we have discussed about the validator, which is the judge that measures the model performance. So you have learned how to load a model and ask it to make predictions and how to measure how well it performed using the validator. So but how does the model get good in the first place? How does it learn from the dataset so that the validator gives it high scores? This is the job of the trainer. So we'll be talking. So imagine our AI model is like a student athlete, okay? It has a potential. Potential is the model architecture and has some initial skills that is similar to the pre-trained weight. So to get a better and perform well in a competition that is making accurate prediction on the new data, it regularly needs practice, guidance and feedback. This is exactly what the trainer does for the model. So we are discussing this in our chapter 7. So how it manages the training process for the custom models, it combines model, dataset and configuration. It supports the training from scratch or fine tuning. Also, it saves the trained OS at .pt files. This is the central component responsible for the entire learning process. It acts like a coach guiding the model through practice sessions using the data from your dataset. It iteratively shows the model examples, checks its performance and those examples, how long its predictions were, and then helps the model adjust its initial or the internal parameters or the weight to get less wrong at each time. So this process is repeated many times until the model becomes a highly skilled expert. So what is the main goal of the trainer? So first it take a model, either it is a fresh or a pre-trained, and then it take a data set. It take a data set with a training and validation split. Later it apply the configuration settings which we discussed in our chapter 4, like how long to train, like for epochs, or how many examples for practice step or batch size. Then repeatedly it show the model data, calculates its errors which is also known as a loss, and update the model's parameter to reduce these errors. And it periodically use the validator which we discussed in our last chapter, in chapter 6, to check the model's performance on the on-scene data or the validation set and track the progress. Later we save the model progress and eventually the final best performing model. So the primary way you interact with the trainer is through the model.train method, which we will be discussing briefly. So this is our model.train. So putting this trainer to work, starting the training, how do we do that? So for that, let's revisit the simple example given in here, provided here. So you can see. So first, using this YOLO 8bm.pt, we load our model and we are loading the pre-trained weight. So the trainer will then fine-tune these weights on our custom data. This is the common technique called the transfer learning as well. So we have been doing the transfer learning, and then this model.train. So this is the model.train, all right. This command initiates the training process. When you call this method on YOLO object, this YOLO class internally creates and uses a trainer instance appropriate for the model's task. This trainer instance will be created. So for example, it can be for the detection trainer if YOLO v8n.pt, which is this is the detection model. Now it will know that it is for the detection, and the data will be also be loaded here. YAML file is loaded here. This is the essential argument that tells the trainer about the necessary or the essential dataset configuration where it is located, and this trainer it reads this file to find the path to your training and the validation images, labels and the class names. So here epochs equals to 50 means this tells the trainer to go through the entire data set or training data set 50 times. That means one epoch is one full pass through the training data. So when you run this code, you will see a lot of output in your console showing the training progress, epochs number, different loss values, measuring the error, validation, matrices like MAP calculated periodically by the validator, which we discussed in late next or previous chapter. So validator using by that you will see different outputs or what is really happening at the time. So let's look at this training loop or the course. This is our course which is in action. The core of the trainer work is the training loop. It is an iterative process where the model launches step by step. Alright. So let's look at this simplified view. So first it is the setup. The trainer initialize everything. It gets this configuration from this chapter 4 we discuss about from the defaults or your data.yml or the arguments like epochs. Next, it sets up the model on the correct device, like it is whether to use CPU or GPU, and also load the initial weight. So, and after that, it also sets up the optimizer. For example, or there are different optimizers. We have not discussed about this. These are the algorithms that are useful to adjust the model's weight. For example, we use Adam optimizer. It also prepares the dataset into efficient data loaders for the both training and validation split. So next, for the epoch loop, the trainer starts a loop that runs for a specified number of epochs. For example, 50 or 100 or even 5. Next, the training steps, which is the inner loop. So this is I have provided this as well, but this is quite difficult to visualize. So as I mentioned, in the inner loop inside each epoch, the trainer loops through the entire training data set in small groups called batches. That means at a time you can send the 50 look here we are the loading the data batches or others, and so for example it is a process start training batch loop. So whether for example if you have 50 total images and you have the batch size of 10, then it will run for 5 times. So inside each epoch the trainer loops through the entire training data set in small groups called the batches controlled by the batch configuration setting. And for each batch it loads image and the batch and the labels. Okay, so for example the images, sorry, it loads the images and the labels corresponding ground truth labels from the training data set. And next it feeds this batch through the model like forward pass to get the model predictions. So it will model instant, this is our heart or our brain, it will pass it. So it is also pre-processing action is happening here. So next it calculates the loss or numerical score it is and it indicate how far our model prediction were from the ground truth level from the batch. For example, the less loss means the better performance. Next, the gradients are calculated. So gradients is a mathematical indicators of how each model parameter should change to reduce the loss. So this is something like a derivation. If we look in the mathematical equations, so we have the gradients or the derivatives functions, which tells us del x, which is something small value that need to be changed every time based on the model performance. Then it updates the model parameters using that optimizer as well as that gradients by from the backward pass. Next this is also known as a learning step. Next is a validation step. All right, after a certain number of batches or typically at the end of each epoch, the trainer pause for some time and runs the validator. So this validator it is very useful for calculating the performance matrices like MAP. So for example, on the data that it has not been training on, this trainer will record these matrices, and this is very important to ensure that the model is learning well. Also we need to ensure that the model is not memorizing the training data. For example, if you are a coach, then you want your student not to follow the similar pattern not to remember or not to memorize the thing, but to train and based on that learn. So as a student also the teacher wants the student to understand the concept better, not just to memorize the things for the exam. So this is the same thing. So memorizing the, not just memorizing, the overfitting is also must be excluded here. And checkpoint saving is another. So as I mentioned here, checkpoint saving is another step where periodically the trainer saves the current state of the model and the optimizer. Okay, and these checkpoints allow to resume training if it is interrupted, or to go back to the earlier version of the model if needed. So we have our checkpoint here. So we run the model, we validate, our trainer is taking the track. So these checkpoints allow to return back, as I mentioned. The for example, the starting we use YOLO V8 9 PT. Like that, we will be shaping this checkpoint such as best.pt, that tracking the best result. And we can improve, or for example, if the result improves, then it can be updated. At the end of the training, or after completing all the epochs, the trainer finalizes the process and shapes the best model with best.pt and compiles the training summary. This is this iterative process of forward pass and look forward pass, and loss calculation, forward pass, loss calculation, as well as parameter update combined with periodic validation is the core of training deep learning models. Basically, there are different trainers based on our tasks, for example, detection, segmentation, as well as the classification. So base builder, as similar to our predictor and the validator, there is also the base trainer which provides the fundamental structure. And the workflow for the training any model, like managing epochs, batches, optimizers, learning rate, schedulers, checkpointing, and calling the validator. You can see this in the box. And task specific trainers include detection trainer and the segmentation trainer, which inherit their characteristics from this base trainer. And setting of the task specific data set that know how to load the labels in the right format of the task. So loading the correct type of model is important for the task, and defining or selecting the appropriate loss function for that task is also carried out. Model detecting model, like it helps to detect whether it is for detection or not, or detecting some loss and detection validator. So it is doing all the things. So when you call this model train, the YOLO class automatically determines the model task and initialize the corresponding task specific trainer. Alright. So on this is what happened under these things. So basically, the task trainer is the main. The task trainer is the main thing here. It manages the overall training loop, interacts with the training data set and the validation data set. Above all, it is also useful for via data loaders, and feeding those data loads into this AIM model instance. It calculates loss and updates the weights and call the task validator. So we have already seen all these things. So this also can be obtained from this GitHub. Now we'll be talking about the next chapter in the next video, but before that, let me conclude by summarizing the things we covered today. For example, we talk about the trainer, which is the essential component that acts as a coach. So it acts as a coach, and also which guide our AI model through the learning process. We saw how this model.train method initiates the process, use our dataset as study material, and following the rules set by configuration. We explore the iterative nature of training loop, processing data in the batches, calculating errors, loss, updating the model's parameters, and periodically checking progress using the validator. So this is everything here written here. You can pause the video and look everything in detail. Understanding the trainer gives us insight on how our model goes from novice, or from the initial step to the expert step. That means which is very good at detecting the particles. So after the training is complete, the trainer or the model.train provides a summary of everything that happened during the training run. In the next chapter, we will examine the results. This is the results object which holds the output of tasks like training, validation and prediction. We will be covering that. See you soon. Thank you.